Hi students, in this video we are going to discuss regarding number of p pi p pi bonds and number of p pi d pi bonds in the molecule. Okay, so for this we need only the hybridization of the molecule. Hybridization of molecule. If you know the hybridization of molecule, we can easily find the number of p pi bonds and number of p pi d pi bonds in the molecule. So on this hybridization, already I made one video. I will provide the link in description, so you can watch that hybridization concept. Okay, right. So now we will take one example and explain this number of p pi and number of p pi d pi bonds in the molecule. So for the example, I am taking like a SO3 molecule I am taking. So what is the hybridization of SO3 molecule? So according to our shortcut method, so number of what is the central atom here? Central atom is sulfur. Sulfur has a 6 electrons in the outermost orbit. 6 electrons in the outermost orbit. Right. So it has surrounding atom is the oxygen. We have 3 oxygen atoms and oxygen valency is the 2. So simply it can form the 3 sigma bonds with the central atom and the 3 pi bonds also it is forms. Now what is the hybridization? Hybridization is equal to what? Always number of sigma bonds that equal to what here? Hybridization number of sigma bonds plus number of lone pairs. So simply we can say hybridization that nothing but the number of sigma bonds plus lone pairs. Lone pairs. Anyway, on this central atom there is no lone pair here. Now only 3 sigma bonds are there. So there is 3 sigma bonds, which means sp2 hybridization. So from the hybridization, how to find the number of p pi bonds and number of p pi d pi bonds? Right. So for this, we need to know the first how many number of pi bonds are there in the molecule. So for the number of pi bonds, we will be having simply formula here. So total number of pi bonds is equal to what student formula? Total number of pi bonds that equal to the number of oxygen atoms minus charge. Okay, in this pi bonds, how many number of p pi bonds are there? So p pi bonds that is equals to the number of unhybridized p orbitals. Number of unhybridized p orbitals in central atom. This is the number of p pi bonds. I will clearly explain how it will be. Next one, how many number of p pi d pi bonds are there? P pi d pi bonds that equal to the total number of pi bonds. Total number of pi bonds minus number of p pi bonds. P pi bonds. Right. So with this example, we will explain the number of p pi bonds and number of p pi d pi bonds in the molecule. If you observe carefully, in this SO3 molecule, total number of pi bonds are the 3. So we can give the number of oxygen atoms are 3 here. There is no charge over the molecule. Simply total number of pi bonds is how much? It is 3 only. Right. In this, how many number of p pi bonds are there? P pi bonds are number of unhybridized p orbitals. Generally, in the outermost orbit of the sulfur, it has the 3 p orbitals are there. 3 p orbitals are there. In these 3 p orbitals, 2 orbitals already involving in the hybridization. Okay. So remaining 1 orbital is the unhybridized p orbital. That is our number of p pi bonds. So simply we can say 1 p pi bonds are there. And what about the number of p pi d pi bonds? Here p pi d pi bonds will be total are 3. P pi bonds are 1. P pi d pi bonds will be the 2 only. Okay, right. Another example we will see here, which is I am taking SO2 molecule I am taking here. In the case of the SO2 molecule, what is the number of the p pi bonds and p pi d pi bonds? For this, we need hybridization of the SO2 molecule. If you observe here, central atom is sulfur. Sulfur has 6 electrons in the outermost orbit, and surrounding atom is oxygen. Oxygen valency is 2. It forms the 2 sigma bonds with central atom and remaining these two we can consider as a lone pair of electrons. Now hybridization, that's nothing but what here? Hybridization is equals to the sigma plus lone pair here. Sigma is the 2, lone pair will be the 1, so which is the 3, which means hybridization is the sp2 hybridization. If it is sp2 hybridization, so let us see what is the number of the total number of pi bonds here. Total number of pi bonds will be the number of oxygen atoms are 2. There is no charge over the molecule, which means total number of pi bonds, how much it will be? It is 2. In these pi bonds, number of p pi bonds, that will be the, it is sp2 hybridization. One p orbital will be the unhybridized p orbital here. We can say here one is the number of p pi bonds, and the remaining that nothing but the p pi d pi bonds. That nothing but how much it will be? It is 1. Another example we will see here, which is the PO4 3 minus. In the case of the PO4 3 minus molecule, central atom is the phosphorus here. Phosphorus has the 5 electrons in the outermost orbit generally, but it has the 3 minus cities over the molecule, which means what? 3 more electrons we need to add to the central atom. Right. So there is the 4 oxygen atoms are there, which means it forms the 4 sigma bonds to the central atom. And let us see what is the hybridization. So hybridization will be the sigma bonds plus lone pair. There is no lone pair of electrons on central atom here. Simply we can say 4. We can say here sp3 hybridization. Okay, right. Now if you see total number of pi bonds here, pi bonds is equals to the, here number of oxygen atoms are, it is 4, and the charge over this one, it is the 3, it is there. Okay, that means number of pi bonds will be the 1. In this number of p pi bonds will be the 0 only. Why it will be? Here it is the sp3 hybridization, which means all the p orbitals in central atom, it will be undergoing hybridization. Okay, that's why p pi bonds are 0. Now what is the p pi d pi bonds? P pi d pi bonds are the 1 only here. Okay, right. One more example, if you see here, I am taking here SO4 2 minus molecule I am taking here. In this SO4 2 minus molecule, central atom is sulfur. Generally, sulfur has 6 electrons in the outermost orbit here, and there is a 2 minus it is there, which means 2 more electrons we need to add. There is a 4 oxygen atoms are there. These 4 oxygen atoms forms the bonds with the central atom here. 4 sigma bonds formation takes place, which means hybridization is, which is sp3 hybridization, this central atom. Now what is the number of p bonds? What number of pi bonds here? Pi bonds is equals to the total number of oxygen atoms are 4 here, and the charge over the molecule will be the 2, and simply we can say number of pi bonds will be the 2. Okay, now what is the number of p pi bonds? Here p pi bonds also it is 0. Why? Because here all the p orbitals in central atom, it is undergoing hybridization. Right. Now what is the p pi d pi bonds? P pi d pi bonds are the 2 p pi d pi bonds are there. Okay, right. Another example I am going to take here, ClO4 minus. ClO4 minus. In the ClO4 minus, here central atom is the chlorine. Chlorine has the 6 electrons in the outer, sorry, chlorine has 7 electrons in the outermost orbit. 7 electrons in the outermost orbit, but it has the negative charge over this molecule, which means 1 more electron we need to add here. Okay, right. There is the 4 oxygen atoms, which means forms the 4 sigma bonds. Right. Now what is the hybridization of the molecule? Hybridization of the molecule will be the, it is sp3 hybridization. Now if you come to the number of pi bonds here, number of pi bonds are the 4 oxygen atoms are there, minus 1 charge it is there over this one. Simply we can say number of pi bonds are 3. The number of pi bonds are the, what is the number of p pi bonds? P pi bonds will be the, it is 0. Why? Because all the p orbitals in central atom, it is undergoing the hybridization. Now if you come to the p pi d pi bonds, p pi d pi bonds are the 3 p pi d pi bonds are there. Okay, right. So this is what trick to find the p pi bonds and p pi d pi bonds in the molecule. For more videos, please subscribe my channel. Thank you very much.